One of the questions that comes up most often is how much of an impact speed has on efficiency and range with EVs. Today I have a 70 mile per hour versus 60 mile per hour efficiency test for you in my Kia EV6 Wind all-wheel drive running the stock 19-inch wheels, and the results might surprise you. With how often this question comes up, I wanted to get some actual numbers to provide people as opposed to the typical statement, the faster you go, the less efficient your vehicle is. I figured I'd test 60 miles an hour versus 70 miles an hour to illustrate the impact of speed and to get an idea of what you can expect on the highway. I also wanted to test it because I have something coming up that I'm doing to the car that might change the efficiency, and I wanted to get a good baseline to compare to. For the testing procedure, I'm not doing a terribly long test since I'm not testing range, only the miles per kilowatt hour efficiency. So what I'm going to do is run down the interstate from one exit to another at a consistent speed, get off the exit, and turn around and come back. That should eliminate any impact elevation or wind has on the calculation. The route there and back is around 13 miles or so, which should be sufficient to give a pretty accurate efficiency figure. I'll be sure to drive consistently at the exit too, slowing down and accelerating in a similar manner to minimize any impact that might have. I'll be in the normal drive mode since that's what I typically drive in, and I think it's likely the most commonly used. Normal mode in the all-wheel drive EV6 generally only powers the rear wheels unless you press the accelerator a decent amount, indicating you want more power, and that's when it powers the front wheels too. Honestly, on the highway at a consistent speed, I rarely see any power going to the front wheels. The climate control system is also off to eliminate any impact heat or AC could have on the test. I have my OBD2 adapter connected to the car scanner app too, so we can see more detailed battery information like the state of charge, battery temps, that kind of stuff. So I'll begin with a 70 mile per hour test. To get started, I'll go ahead and get on the highway here, up this initial hill, and reset the meter at the top of the flat section when I'm going 70. That way it reduces the impact of acceleration on that initial hill. And on the way back, I'll stop the test at the top of that hill before coming down, so that doesn't impact it either. For any of you doing your own testing, you do have to be on the after recharging screen to reset it. This drive info screen that I'm on right now doesn't reset. So I just reset it, and we've got the highway drive assist set at 70 miles per hour, so we're just cruising. It's 56 degrees outside, and the battery temps are in the upper 60s, which is good. And the true BMS state of charge is at 48%. So we'll just drive and see what we come up with. One thing I wanted to note, the tire pressures are all around 37 to 38 psi, which is where I keep them for normal driving. Alright, coming up on the exit here for the U-turn after about 6 miles, we're showing about 3.3 miles per kilowatt hour at this point, which is decent for 70 miles per hour. The BMS state of charge dropped from 48% to 46%. Battery temps are still roughly the same as where they were to start, and the outside temp has dropped a few degrees to about 52 degrees now. So we'll go through this light and hop back on the highway in the other direction. Now getting back on the highway after 6.5 miles, we're showing 3.8 miles per kilowatt hour since we had a little regen and some low speed driving. Everything is still roughly the same for the battery temps, and the BMS state of charge is now at 45.5%. So we'll go ahead and get back up to speed here and resume the test. Alright, now 10.5 miles in, we're showing 3.4 miles per kilowatt hour. Temps are still looking good, and we're at 44% for the BMS state of charge. Now closing in on the end here at about 13 miles, we're showing 3.5 miles per kilowatt hour. That's pretty solid for 70 miles an hour. Showing 43.5% for the BMS state of charge, so it's dropped about 4.5%. It does go by 0.5% increments, so it's not super precise, but that is about 3.5 kilowatt hours on this battery pack, which also does translate to around 3.5 miles per kilowatt hour, so that's good, those numbers do correlate. But yeah, 3.5 miles per kilowatt hour is good. That's about 270 miles of full range with no heat or AC going. And realistically, that's about 190 miles of range between 10% and 80% at 70 miles an hour. So it's pretty good. Now on to the 60 mile per hour test here. We're at the top of the hill, so we'll reset the meter. We're currently at 42.5% BMS state of charge. Battery temps and the outside temp are basically the same as they were in the 70 mile per hour test. AC and heat are off. So here we go. Getting up to the exit here, we're at a whopping 4.6 miles per kilowatt hour right now, which is much more than I was expecting. We're at 41% BMS state of charge and the temps are still consistent. So we'll get off the exit here. There was a slight incline, so it did drop to 4.3 miles per kilowatt hour now at 6 miles, which is still really good. That's right at 1 mile per kilowatt hour more than the 70 mile per hour test at this point. So I'll show this full portion here. I did forget that they had changed this exit format a while back, and I was supposed to be in the right lane during the 70 mile per hour test when I did the U-turn to go back the other direction. So to be consistent, I'm taking this same route around to get back on the highway. The good news is this shouldn't have much of an impact on things since it's not far out of the way and I basically had the same experience during both tests. Now looking at the battery info, temps are staying where they've been all evening. Right now the BMS state of charge is at 41%. And we'll go ahead and get back on the highway here. Trying to accelerate in a similar manner to the 70 mile per hour test. And back at 60 miles per hour, showing 4.3 miles per kilowatt hour right now. 40.5% for the BMS state of charge, with the temperatures continuing to stay consistent. All right, now nearing the end here, and I'm showing 4.4 miles, 4.3 miles per kilowatt hour. The BMS state of charge is now at 39%, dropping only 3.5% over the test, 1% less than it did during the 70 mile per hour test. Temps are where they have been all night, but yeah, 4.3 miles per kilowatt hour. That's awesome at 60 miles per hour. That's 0.8 of a mile further you can go per kilowatt hour at 60 miles per hour versus 70 miles per hour. For an entire charge, that equates to roughly a 60 mile difference, bringing it to right around 330 miles total, which is really good. For 10% to 80% at 60 miles per hour, you're looking at around 230 miles, 40 miles further than at 70 miles per hour. From this, we can estimate other speeds too. At 65 miles per hour, you're probably looking at around 3.8 to 3.9 miles per kilowatt hour in these same conditions. At 75 miles per hour, expect it to drop to around 3.1 to 3.2, which is about what I've seen. So I'm excited to be able to provide this comparison for you guys. Hopefully this helps answer a lot of the questions that you have on efficiency. I'm also really excited to have this as a baseline to reference for future tests. But anyway, let me know what you think in the comments section. Be sure to subscribe to the channel too. I have a lot of content in the pipeline for you guys. I have a giveaway going on right now, so check out that video, and I have several more lined up that I think you're going to love. I also have a lot more videos coming too, so stay tuned. Thanks for watching, and I'll see you in the next video.